So, quick show of hands, how many game developers in the audience? Excellent. And how many of you have heard about Hashgraph? Okay, a few hands. So hopefully at the end of this presentation, you will know a lot more about Hashgraph. So I am here to explain a little bit about Hashgraph and Hedera. And I head up our marketing efforts over at Hedera. And a little bit of an agenda so you can follow along. I'm going to do a little bit of a history lesson, then I'll get into introducing you to the actual technology itself and the platform, and then some actual applications of how we might see this being applied by game developers in the game world here. So first question, if you know any of these, shout them out. What game is this? Anyone know? No? Okay, 5000 BC, this was a primitive dice game. Next one. Any ideas? Okay, yes. It is a precursor to Mahjong. This is the ancient game of Sir, about 3000 years BC. And so what's the pattern here? Basically, as humans, we love to play games. And every time we have some technology, we usually build some tools, we might build weapons, but we also build games. And so very early on, first basic computer game, electromechanical, anyone know? What is this game? This is the Nimitron from 1940. And then a little bit later, does anyone recognize this? This was called Tennis for Two. This is a precursor to Atari's Pong. This was from 1958. So every time we had a technology advance, the first computer, we built the first game. And then this one blew me away, actually, when I did some research. Does anyone recognize this game? This was a first in many regards. This was in the 1960s. This was the first-person shooter game. It was the first game to be played over the internet, at that time called ARPANET in the early 1970s, and it was the first virtual reality game. It's called Maze Wars. So that just knocked off a lot of firsts. And then we go to this one. Everyone knows this game, right? The first real-world application that everyone could use of augmented reality, Pokemon Go. And then still probably the only useful application that we can all use, what's this one called? CryptoKitties. So that is where we are today. We have a very popular game on blockchain technology, and it is the game developers here that are really going to help take this technology mainstream. So as I tell you about Hashgraph and why we think it is the ideal solution for games and to build upon for games, start to think about where can you take this thing next. So a little bit about our two co-founders, Dr. Lehman Baird, PhD from Carnegie Mellon, and Mance Harmon. So they actually met way back in 1993 when they worked in the Air Force at a computer lab in the Air Force. And they were working on machine intelligence, the precursor to artificial intelligence. And games are in their DNA, not the type of game you're maybe thinking about, but Mance actually was responsible for running the simulator for the original War Games application. So this advanced artificial intelligence is something that they've been thinking about for a long time. And they've worked together at many startups, and together they are responsible, Dr. Lehman-Baird for the Hashgraph consensus algorithm, and then Mance is our CEO. So what is Hashgraph? Hashgraph is two things. It is a next-generation distributed ledger technology. So we like to think of it as a fourth-generation type blockchain. First generation was Bitcoin. Then people thought, okay, the underlying system that underpins Bitcoin is interesting. That's blockchain. Then people thought, well, let's add smart contracts into this, and that was Ethereum. And then Hashgraph is the next iteration of that. So at its core, it is a consensus algorithm. And Lehman thought for many years about how to do distributed consensus at scale. And for a long time, he thought it's not even possible to do that. And he kept coming back to it and thought, I have to have a way to solve this. So the Hashgraph consensus algorithm that underpins the distributed ledger is three things at its core. It is incredibly fast, it is secure, and secures in ways that I will go into detail about, and it is fair. So let's start with fast. To do games, we have to be fast, and some of the blockchain technologies out there just are not fast. So hundreds of thousands of transactions per second fast, and consensus latency within seconds. So let's help you put this in real-world terms. Major credit cards run about 2,000 transactions per second and consensus latency at about 70 seconds. They have to burst to about 50,000 transactions per second. And some of their networks have to ensure they can go a little bit beyond that. Hashgraph is 500,000 transactions per second with consensus latency of just 3.5 seconds. That is blazing fast. And we're very proud of that fact. And these are tests that have been done internally. And as we get close to our public launch, we will have people validating those in the real world. But we believe that it is considerably faster than any other distributed ledger technology that you can build on. So security. Security is incredibly important. I heard the previous speaker, Dylan, touching on this topic. So with a distributed ledger system, we want to know that a set of computers come to agreement on the truth, and that truth is shared by the whole community of computers as well. And there's a moment in time where you know for sure that that is the truth. And that is different from some other blockchain solutions that become more certain over time and more confident over time. That's how they're designed to work. But there isn't a single moment in time where you know for sure that that is the consensus, and that the whole community of computers knows for sure and agrees that that is the consensus. And then in security, we want to be able to ensure that we can survive some malicious nodes, that they can't overtake the network, that we can survive a botnet attack, a distributed denial of service attack, and that firewalls can't shut you out, that even if people try to shut you out, you can still gain access to the network. So all of these things are something called Byzantine fault tolerance. And Hashgraph is Byzantine fault tolerant, but it is also goes one step further than that, and that is the gold standard of security called asynchronous Byzantine fault tolerant. And what that means is that unlike some leader-based systems where you can knock out a computer and then knock off the entire system off of the internet, with Hashgraph, it can survive that as well. So it is the absolute highest degree of security that you can achieve. And then it has something else as well. So let's say we have set up our game and we're exchanging money in our game, and one person requests some digital currency from another person, and their wallet requests that, and it comes back with, that file doesn't exist on the network. How do you know? How do you know that computer is telling the truth? So with the hash graph, you know for sure, because the whole community has to come to consensus that that is the state at that given moment in time. So fairness, this is another thing that makes Hashgraph unique. So fairness is 3 elements of fairness. The first one is that there is a timestamp on each transaction. And this timestamp does not rely on just one computer or one atomic clock. It actually takes all of the timestamps from the entire community of computers. And it orders those very quickly, and it takes the median of that. So you cannot have one computer shifting the time in one direction or the other. So when we think about auctions, for example, what happens if 2 people bid on the same item at the exact same time? How do you know who won that bid? Well, you could take eBay's word for it, and that's putting your trust in a central organization, or you could have a system like this where the whole community comes to consensus on what the ordering of transaction is. Fair access means that you cannot have a group of nodes or one computer that really shuts someone out from the network. Everyone gains access to this. So there are, we believe, 4 fundamental requirements. We've talked about technology and security. What about stability? As a game developer, you want to be sure that the system that you're building on is there today, it's there tomorrow, it's there in 10 years' time. So in addition to the technical controls in the technology, there are also legal controls. So Hashgraph is a patented algorithm, and therefore, as a community, we will prevent it from ever forking, which means that someone can go off and create a new version and a new network, and you as a game developer, you're like, what happened to my game? So it is a stable platform that cannot fork. The good news is, for you as game developers, you do not require a license to use the platform. You do not require a license to use our services. You don't have to have a license to build smart contracts. And it is your software. Whatever mechanism you want to put in place, whatever license you want to put in place, it is yours. You don't even ever have to talk to Hedera. We are publishing the source code as well. So although it is patented, everyone gets to see and review the source code. So the last one is governance. So Hashgraph and Hedera Hashgraph is a decentralized distributed ledger technology. So how do we prevent groups of nodes really becoming centralized, which happens with some other blockchain technologies today? So we will have 39 blue chip companies across different sectors distributed around the globe who are responsible for the good governorship and stewardship of the Hedera Hashgraph platform. And in order to ensure that no one entity can collude with another, every 3 years they will turn over so that we get new members coming in. So this is what the platform looks like. We have the Hashgraph consensus algorithm that sits as the trust layer of the internet on top of the internet. We have our own native cryptocurrency, a file storage system, and then smart contracts that are compatible with Solidity. Okay. So now let's get to some of the things that you can do with Hedera Hashgraph. And I spoke with Lehman before putting together this presentation, and Lehman is very excited about games. He loves to play games, and he has thought of ideas both for the public network and also if you want to use Hashgraph as a private ledger system as well. But for the purposes of these use cases, we're talking about the Hedera public network. Okay, so in-app purchases. This is a very easy one. You can use the cryptocurrency, you can load up a wallet in your game, and every time someone plays a game and achieves a certain result in a game, you can debit the account very quickly. Surely this is a solved problem, though, with Apple or other centralized systems where you can also just have people do in-app purchases. So yes, although you have to give those centralized authorities a rip of your just rewards to do that. And also, you cannot do microtransactions with those. You have to batch them up in some way and debit your account, maybe weekly or monthly. And this, from the get-go, if you're an independent game developer, you can, on day one, start to get users and start to make money off of this. Number two, we talked a little bit about auctions earlier. So let's say I have an item of value. I won this spaceship by completing certain tasks in a game. I now own that. And if you go over to eBay, you can actually buy some of these items that you can use in other games. Well, how about inside of the game, you run your own auction so that I, who own this spaceship, can actually sell it to the highest bidder. And I know that whoever won that auction really won that auction, that someone didn't try and dupe me and gain an advantage by bidding on my spaceship. In games today, there are resources of scarce value. And over time, these things become more and more valuable. So in the Hashgraph, you can store exactly what these items are, where they are in the game. You can make it easy if I won something and I've got 2 of that kind of amulet, that I can transfer it to a friend very easily, and now they can take advantage of it. Something else that makes Hashgraph unique is random number generation. So if you want to build a game where you, let's say, want to have a game inside a game where we're competing and we don't know what that item of value is going to be until we win it, you can do that with Hashgraph through the smart contracts and random number generation. And then storing things as basic as a score. How do you know forever that your score was the highest score or better than someone else's score? So you can store those in the public ledger as well. So what does this mean to the centralized world? And today we've seen the rise of AI, where sometimes as a human, I am competing against someone that purports to be a human, but it's actually an AI-based system, and I might invariably lose. So how you combat this today with a centralized gaming system is you put a watchdog on your centralized server, and you watch and you load it up with advanced machine learning algorithms, and it says, oh, that actually looks like a computer playing. It doesn't look like a human playing. So on the Hashgraph, that is not possible. With a decentralized system, it just is not possible to have a watchdog. And it feels like a losing battle anyway, because AI is getting better and better and better. So Lehman said, in that scenario, let's change the game. So with Hashgraph, you'll be able to see who is playing better and who is playing not so well. So why not pair up the people, the humans who are playing for the love of the game, let them play together one game, and then now you've created a new game, which is whose AI is better? Is their AI better than my AI? So AI plays AI, humans play humans. And just a final note, you have probably heard of Machine Zone, a very famous gaming company. So they have chosen Hedera Hashgraph for a new application that they've been developing, which is a decentralized AI mesh It is called Satori, and you can go and check it out at satori.com. And so hopefully this has been an educational short session for you, and you are starting to think about how you can build on top of Hedera Hashgraph. So thank you very much. Hopefully we've got time for a couple of questions.
Okay, yes, any questions? Is the gentleman here down at the front again?
Thank you. Hello, I'm
Hello.
Sid Francesco, and I have this question. I'm a Solidity developer, so I'm happy that you support Solidity. And but to deploy a smart contract on Hashgraph, I need the Hashgraph, the Hedera cryptocurrency. Right now, it seems to me that only accredited investors can buy that when there will be the selling. So how we developer, how we can have some cryptocurrency so we can...
Thank you so much for asking that question. I really appreciate it. So you are right. Today we are raising money from accredited investor community. The reasons for that are that we want to stay very abreast of SEC rules and guidelines and do nothing afoul of there. However, what is most important to us is building a platform that developers are going to build upon. So we are committed to distributing tokens to the developer community whenever we can. So that is, legislation permitting, but we want developers to build on this, and we want to incentivize developers to build on this. So actually our legal team is really working hard about how we can distribute tokens to the developer community to build on Hashgraph while staying abreast of the SEC. So what I would say is stay tuned for more information there. We are very committed to that.
Okay, one question there. Just wait for the microphone. Oh, there's one there as well. Okay, yeah.
Okay.
Making quick ones. Yeah.
Ben, Nobleblock, just wanted to know, so you're saying you have 39 blue chip companies that are essentially making sure you don't have a 51% attack. Are you doing some sort of like volunteeristic setup to proof of stake, proof of work model? So when you release those tokens, there's going to be scalability with your network, and if not, how are you solving the issues of creating a scalable platform that can host several applications over time?
Yeah, great question. So those 39 companies will all be running nodes in the network as well initially. And then beyond that, we have other organizations that will also be running nodes in the network. And one of the important things for the governing council is to ensure that there is fair distribution among those nodes as well. So initially we'll run in a single shard, and then we hope to scale up very quickly and have multiple shards as well. But yes, absolutely, again, committed to making this as decentralized as possible, which is a knock on some of the existing systems today.
The last question, this gentleman here.
Hello.
Yep.
Question.
Sorry, can you say who you are and where you're from?
Hi, my name is Ian, Horizon Blockchain Games. I have a question. Because your algorithm uses a Byzantine fault tolerance, why did you choose to have a permissioned blockchain with sort of that consortium if you had that algorithm? Because essentially you probably don't need that. But I was just asking why you decided to do that.
Yeah, so there are two aspects to this. So the Hashgraph consensus algorithm invented by Lehman, you are right that you can use that in a permissioned ledger, and that is a company called Swirlds. But the Hedera network is permissionless, and Swirlds has granted an irrevocable license to Hedera to run Hashgraph in a permissionless network. So if you are a game developer and you have an application that you believe that you need a private ledger, a permissioned ledger, you can do that. But if you want to build on the public network, then that is permissionless. And that's where you never need, so I kind of wear two hats because there's the swirled side of things, but today I'm talking about Hedera, and that is completely permissionless. So don't confuse that with the patent, which is designed to protect the community from forks and malicious behavior, but it is free and open to use for everyone.